we did a couple of weeks ago. All right, so 2 questions on the screen. I want you to find the inverse of matrix K and also to find the inverse of matrix P. So you have 2 questions. Feel free, it's not a test, to go back into your notes. It's just to refresh your memory. And if you could, and for those who are able to, if you could send the answers on the chat, I would appreciate that. But if it's too much, this one's kind of hard to type up the answer for. So at least let me know you're finished with the inverse of K and P. Good luck, and I await your participation. The first step in finding the inverse of K, but to find the inverse of any matrix, you have to find what? The determinant first of all. So let's find the determinant of K. I could probably do the work in here. I'll do the work in here. To find the determinant of K, that's the symbol for determinant, the name of the what? Matrix surrounded by 2 solid lines. You're supposed to multiply the more important diagonal first. If you look back in the notes from last week, I will have specifically mentioned that one diagonal is more important than the other. So you multiply the more important diagonal first. So it's -3 multiplied by 2. And you must put what right after, no matter what? A minus sign. And then you multiply the less important diagonal afterwards. So it's 6 multiplied by -1. So let's see what we get here. -3 by 2 is -6. You must put this minus sign here. And 6 by -1 is -6. So remember, 2 minus signs you're going to touch here. Aren't you going to get a determinant of 0? Because -6 plus 6 is 0. So the determinant is 0. What do you call a matrix that has a determinant of 0? There's a special name I gave you for it last week. It starts with the letter S. Right, it's called a singular matrix. Right, now a singular matrix does not have an inverse, but I want to explain why, right? So let's go and find the inverse of K. So it's K -1. That's the symbol for inverse. Remember what you're supposed to do? Whatever you get for the determinant, doesn't matter what you get, you always put it underneath what? A 1. Always, always. So we put the determinant, which is 0, always underneath a 1. And then you put back the big pair of brackets here. The main diagonal, you switch positions. So the 2 will jump here and the -3 will jump here. The less important diagonal, the values do not move. Instead, you look at each value and make it the opposite in the less important diagonal. So the opposite of -1 is +1. And the opposite of +6 is -6. Now, technically, this here, I'm going to surround it by a little cloud, like box it off here. This is the inverse. However, I want to explain why when a singular matrix technically does not have an inverse. I want everyone to take 1 and divide it by 0. Let's see what happens when we try to simplify it. Take 1 and divide it by 0 on your calculator, and something strange will happen on your calculator. Take 1 and divide it by 0. Right? So a lot of people are seeing it there on the calculator. You are going to get an error on your calculator. It's not possible to divide something by 0. But for the time being, it's considered a mathematical problem. Maybe one day that will be solved. Okay? So while technically you have an expression for the inverse, singular matrices in the long run does not have an inverse because you get an error when you try to simplify it on your calculator. All right, so that's a brief revision there. Now, for those who didn't get a chance, find the inverse of P but make sure you find the determinant first, and then you follow the rest of the procedure, right? Take a half a minute, I will begin to work it out. So the determinant, let me use the symbol for determinant, P with two straight lines here. Multiply the more important diagonal first. So it's 7 multiplied by 1. You must put a minus sign right after, and then multiply the less important diagonal. -3 multiplied by -4. So 7 minus 3 multiplied by -4 is positive 12. So end up with 7 minus 12. I think we're getting -5. Right? But a lot of people put positive 5, my mistake, but it's -5 and not positive 5. 7 minus 12, I guarantee you, is -5. So let's find the inverse now. To find the inverse, oh, that's a different color. Use green. Right? No, by the way, the inverse is -5. If they ask you what the inverse, sorry, the determinant is -5. Let's put DET for determinant. A lot of people are telling me the determinant is 1 divided by -5. No, the actual determinant is -5. When you are finding the inverse, you throw the determinant underneath a 1, but the determinant is -5. The 1 part is only put there when we are doing the inverse, right? So what do we do now? We switch the more important diagonal. 1 and 7 switch positions, but the less important one, we make each one the opposite, but we don't physically move the numbers. So you get +3 and +4. So I hope you all have that on that end. And of course, if you get it wrong, once you understand what your mistake is, take it as a win. Right? 20 seconds and we move on. All right, now I know this looks complicated, right? But bear with me. We're going to learn to solve a simultaneous equation using the matrices method. And believe me, right? Once you master the matrices method of solving simultaneous equation, you just tend not to care about the substitution method or the elimination method, because matrices real powerful and it's make life easy once you get the hang of it. I want everyone to take down this pair of simultaneous equation. Right? From the homework, you would have remembered that in a simultaneous equation, they give you 2 equations. And most of the times, the 2 letters is X and Y. It doesn't always have to be X and Y, but most of the times it will be X and Y. And your job is to solve for X and to solve for Y. You have to get an answer for X and you have to get an answer for Y. In other words, you have to get 2 answers. So if you look at a simultaneous equation, well, at first glance, it does not look like a matrix. You have to make it look like a matrix, and it's not going to be hard at all. Whenever you're doing this, right, make sure the X's come first and they line up on top each other. Make sure the Y's come second and they line up on top each other. And all the regular boring values without X or Y, make sure it's on the other side of the equal sign. Now, as this is our first question, I am putting no tricks in it. The X's are lined up perfect, the Y's come second, and the values without letters come after the equal sign, they come last. I just saying, if it was mixed up, you have to unmix it up, right? Put the X's, then the Y's, and then everyone else. You'll notice it have a number touching X here. The number touching X here is 2. The number touching Y here is +3. What's the number touching X over here? I know I didn't put a value, but it's automatically 1. By now, everyone knows that, right? don't ever assume it's zero. Whenever you see a letter by itself, the number in front is always, always 1. And the number here is 2. And well, you'll get the idea. Anytime you're converting it to a matrix, you will always have a big pair of matrices here, a thin pair, a equal sign, and a next thin pair. So a big, small, equal, and a small. Always, 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 always. What you are going to do now is extract the values and put it in the matrix. Tell me if you see a pattern here. N over here is 2, 3, 1, and 2. So we put 2, 3, 1, and 2. In other words, the values touching X and Y, we extract it. We pull out the numbers and we put it in the same order we see it. The 2 and 3 are on top, and the 1 and the 2 are underneath. Everyone take that down. So you can pretend like you're pulling it out now, and like you pull out the 2, and you put the 2 over there, right? So like Legos now, like you pull out the Lego blocks and you put it somewhere else. Right. So in the big brackets, the numbers touching the letters go over there. Who comes first in both equations? Who comes first, the X or the Y? But when you're reading the equation, who comes first? The X, right? Because the X comes before the Y, right? You put the X on top and the Y underneath. Whichever letter comes first, you always put it on top. Whichever letter comes after, you put it underneath. Put the X and Y in, please. Anybody want to take a guess what 2 numbers go over here? Because you have an equal sign here. What obviously goes over there? Using a little bit. Right. 17 and 10. So you just did the first step. You took a simultaneous equation and you converted it into a matrix. Now, before we move any further, right, keep in mind that we want to solve for X and we want to solve for what? Y. So quick question. Let's give me a little space in this little bubble here. In maths, when you want to solve for a letter, let me say I had a very simple equation. Let me say I had X plus 3 is equal to 7. And I wanted to solve for X. And anytime you're trying to solve for a letter, you just want that letter on one side and everybody else on the other side. So what you would do, you would take the positive 3 and throw it across and get what? -3, right? Yeah, somebody said it a little bit better. You make X the subject. You've been learning that since last term. So in maths, it has a general rule. Whenever you want to solve for a letter or letters, plural, you keep all the letters on one side and you throw everyone else on the other side. Also, when you throw something across, by now, we know we get the opposite. The opposite of positive 3 is -3. So keep those 2 concepts in your head. I'm going to say it back. If you want to solve for a letter or letters, keep the letters on one side and you throw across everybody else on the other side. But anybody you throw across has to become the opposite. A very, very simple concept in maths. So, what's the aim of a simultaneous equation? Isn't it to solve for X and isn't it to solve for Y? So that means if I'm trying to solve for X and Y, I need to keep X and Y on this side and throw everybody else who is not X and Y on the other side. But, so that means we have to grab this whole matrix here, the one with the 2, 3, 1, and 2, right? So when we throw across the matrix has to become the opposite. Take a guess, guys. What's the opposite of a matrix? called? Give you a hint. We kind of just did it. It starts with the letter I, the inverse. And that is why I was showing you the inverse of a matrix, right? Now, we got to be careful. When you throw across the matrix, it can only jump across one matrix, because let me tell you what's going to happen. And when you take this matrix and throw it across, and it can land here, a part tick, or it can land after. And when you throw across this matrix, it can land before the 17 and the 10, or if you throw it real far, it will land after the 17 or 10. It makes a huge difference where it lands. Whenever you throw across a matrix, it can only jump across one matrix. So that means it will land where the tick is. Because when you're throwing across the matrix, isn't it jumping across the X and the Y? That's the one matrix it will jump across. Now, a lot of people, they have problems understanding that, and I want to explain why, right? Does it have any place for it to fit over here? Look at there. Does it have any place there? When you throw across this big matrix, I'm telling you, it have to reach, it have to go over here. Does it have any space? The answer is no, right? So your brain will automatically think, but it have no place before the 17 and the 10. I'm going to throw it after the 17 and the 10. You cannot do that. Instead, when this matrix goes across, it will push the 17 and the 10 around to make space, right? So do me a favor. Everyone find the inverse of this matrix for me. Because when we throw across the matrix, it will become the inverse. And I need to put the inverse over here. Because when we throw across the matrix, we will only have X and Y living on this side. The 17 and the 10 will get pushed around. And who is going in this space here? The inverse. Because when this matrix lands on the other side, he has to become the opposite. And the inverse is the opposite of a matrix. So quickly, guys, find the inverse of this matrix for me. Yeah, finding the determinant is part of the matrix, is part of the inverse. Remember, you cannot find the inverse of a matrix without finding the determinant. Yeah. When the 10 swings up to the top, you have the 17 and the 10. The 17 goes here, the 10 goes here, but that's right. Don't let the 1 and the 1 over the 1 get to you. The 17 and the 10 get photocopied underneath as well. You multiply each pair. So let's multiply each pair here now. I'll put my multiply sign. Right. Great. So where's my calculator? Well, I don't have my calculator. I didn't come to class prepared. Oh, I found it. Right. 17 by 2 is 34. 10 by minus 3 is minus 30. Minus 1 by 17 is minus 17. And 2 by 10 is what? 20, right? So to get the number on top, we add the two final values on top. And to get the number underneath, we add the two final values underneath. So 34 plus, well, plus minus 30, a plus and a minus is a minus. So end up with 34 minus 30, which is what? 4. And minus 17 plus 20, which is 3. And don't forget, we have a 1 divided by 1 outside. Okay? Great. Right. Everyone okay so far? The 10s, look for your mistakes. The 10s swing up to the top. Like you're, well, I'm not going to repeat it. Just look for your mistakes there. Look for your mistakes. Look for your mistakes. We are almost finished. We are almost finished. Right. So when we simplify this big portion here, we get two answers. Now, how much is 1 divided by 1? How much is 1 divided by 1? 1 divided by 1 is 1. So I simplified it. 1 divided by 1 is 1. Now to finalize, to simplify it, every 1 in the brackets gets multiplied by the value outside. Both of them get multiplied by 1. So we have x and y here. 1 multiplied by 4 is 4. 1 multiplied by 3 is 3. We are finished. X is equal to 4 and y is equal to 3. We have just solved the simultaneous equation. We're going to do a second. We have 3 examples planned out today. If you didn't catch the first one, don't worry. We have a next one to do. But the aim here is, what I'm realizing, what's causing the most problems is that we're not, most people are having problems finding the inverse of the matrix, right? That's where I'm getting most of the questions. Let's take a sec. All right. So everyone take down this. Oh, that's not. Somebody wants me to go back. That's not. All right. Take 10. All right. So the question has changed. Everyone take down the simultaneous equation, and I'm going to go through it slowly again. And also, signs are very, very important, right? All numbers have a sign. If something is positive, well, in math, if something is positive, you just get away from not putting the positive, right? But if a value is negative, you have to put the negative sign. All right, so let's go. So make sure the x's are lined up on top of each other. Yeah, the two x's are on top of each other. The two y's are on top of each other. And what? The two numbers are on top of each other. And it's on the other side of the equal sign. So this one perfectly line up. In other words, I'm not trying to trick you. You will always have a big pair of brackets followed by a small pair, by an equal, and a next small pair. Will always be that pattern. I'm going to make a mistake on purpose. And I want you all to tell me what the mistake is. We're supposed to extract the numbers touching what? The x and the y, right? So it have 2 and 4 and whatnot, right? So 2, 4, the two numbers here are 3 and 3. 3 and 3. What's the mistake that I made on purpose? I'm doing something on purpose. Javid, correct. Sapphire, correct. Tariq, correct. Oh, so much. Okay, right, people got it. Right, Petra, correct. Right? So, isn't this minus sign belonging to the 3? I just wrote it far away, but we all know that minus sign belongs to that 3. So I can't forget it. I have to put that minus 3 there. Otherwise, that whole question will blow up. Like, it will not work, right? It will just be like an atomic bomb, right? X comes before Y, so we put the X here and the Y here. And common sense would say 22 and 24 go over here. Take down up to there. Remember, this portion here is the inverse. Okay? Right. So we have to solve for who? X and Y. That's the aim of the question. We want to solve for Mr. X and we want to solve for Mr. Y, which means we have to take this portion of the question and throw it across. But when he goes across, he will fall over here between the equal sign and the 22 and the 24. And when you throw something across, you get what? The inverse. So don't worry, the inverse will push the 22 and 24 around to make space. Find the inverse of this matrix and put it over here. Don't worry, the 22 and the 24 just got pushed around. And you have who on this side? X and Y. Because X and Y is alone on this side. So this is the part where most people are making the mistakes or where we're getting the most questions. Let me say back what you need to do. You have to find the inverse of this matrix, the same exact thing that we revised at the beginning of class. You find the determinant, you throw it underneath a 1, and then you do some switching up of the values. Take a second shot at it. Let's see if we get it correct. Let's find the determinant. 2 by minus 3, you multiply the more important diagonal. You must put a minus sign. And then 3 by 4 is what? 12. So you end up with minus 6 minus 12. Yeah, that's minus 18. I'm real sure the determinant is minus 18. Whatever you get for the determinant, today the determinant is minus 18. Throw it underneath what? A 1. Always, always, always. Right? We have to switch the more important diagonal. Now, before a couple of people asked why we switch the more important diagonal. I really don't have an explanation. It's one of those things that I grew up just doing. I'm sure there's a mathematical reason, but that's just the formula or format, right? So I'm asking you just to memorize the format. So switch the 2 and the minus 3. So the minus 3 jumps here. Mr. 2 jumps there. We switch positions. The other diagonal, the less important one, once again, we do not move the less important diagonal. We just look at each one and make it the opposite. What's the opposite of positive 3? Minus 3. What's the opposite of positive 4? Minus 4. Are we good up to there at least? We threw this matrix across, and according to the laws of maths, it has to become the opposite. And the opposite of a matrix is the inverse of a matrix. What we need to do now is multiply out or simplify the matrices. Don't let the 1 on minus 18 get to you. You let Mr. 24 swing up to the top. Let the 22 walk here. Let the 24 walk here. Right? We get some space here. Right? And the 22 and the 24 get photocopied here. See if you can take it from there. Right? No, it's a little bit cramped, but what will you do? Let's work it out here. We got different colors. It'll be easier. 22 by minus 3. Let's clear some space here. God, so limited space here. 22 by minus 3 is minus 66. 24 by minus 4. That's all right. 24 by minus 4 is minus 96. Okay, you have a next 22 by minus 3. So that's minus 66. And 24 by 2 is 48. Right? So we have X and Y here. To get the final answers on top and underneath, let's add it. Minus 66 minus 96. I'm getting minus 162. And underneath, if I add the two values, minus 66, that's now, minus 66 plus 48, I'm getting minus 18. Looking correct there, guys? All right, well, not everyone got it, but look for your mistakes, right? It's just a simple addition. You might just type something wrong on your calculator, right? Remember, a plus and a minus is a minus. And don't forget, we have 1 divided by minus 18. Now, in the last question, we had 1 divided by 1, right? So that confused a lot of people. What happens now is that everyone inside the brackets gets multiplied by how much? 1 over minus 18, right? So I don't know if you remember this in maths, right? Like if I have 1/5 multiplied by 10, isn't this the same thing as 10 divided by 5? Or if I have 1/6 multiplied by 36, isn't this the same thing as 36 divided by 6? Everyone can see the relationship there, right? What I'm saying is, don't let the 1 on minus 18 get to you, right? If everyone inside here gets multiplied by 1 over 18, isn't this the same thing as 162 divided by minus 18 and minus 18 divided by minus 18? Everyone inside here just gets divided by minus 18. So you just need to type in this on the calculator and this on the calculator, and you finish the entire question. The x value is on top and the y value ends up underneath, right? Don't worry, we have one more. We have one more after this. And this is what I'm getting here, guys. I'm getting +9 and +1. We're finished. X is 9, Y is 1. And I guarantee you, if you had used a different method, like substitution or elimination, you'd get the same two answers, 9 over 1. Look for your mistakes. Like even if you're not 100% sure as yet, that's okay. Want it increasing. If the first question it was just about 20% sure, and now you're about 60% sure, that's an improvement. We have one more question to bring you to 100%. Right. Take 20, take. If you now join class, you can take a screenshot, right? All right, so let's handle this third question. Let's see if we can fill in all the blanks here, right? Right. No big set of tricks here. Just pointed out, that's the obvious. X here is really 1x. There's no examiner is going to put in anything here. And this minus y is the same thing as minus 1y. I want everyone to start off the question without my help first. I'm giving you a 5 minutes head start, right? Even if you're not 100% sure on how to do it, still try it, right? Make your mistakes. It's better to try, get it wrong, than just wait for me to work out the whole thing. 5 minutes and I'm going to jump in. Good luck. So let's extract the values. It's 1, 3, 4, minus 1. You put a x here, you put a y here. 21 here, 6 here, right? Make sure you had the minus. This is minus 1, and make sure you had a minus sign there, or everything falls apart. So we have to take this matrix now and throw him across to get what? The opposite. Well, the inverse. What did you all get for the determinant? Just for the determinant. Let me see. It's 1 multiplied by minus 1. You multiply the more important diagonal first. Minus, you must put a minus. And then you say 4 by 3. So it's minus 1 minus 12. I get in minus 13. Minus 1 minus 12 is minus 13. Right? So you have x and y on this side. The minus 13 goes here, and you put a 1 on top. Let's find the inverse. Number the 21 and the 6 got pushed around. Let's switch the main diagonal. The minus 1 jumps here, and the positive 1 jumps here. The less important diagonal does not move. We just make them the opposite. So you get minus 3 here and minus 4. Right? I'm being told, right, that I have the determinant wrong, right? This is the last question I have on this particular topic. So try your best to get it on this one, right? I don't have a next one prepared right now. Right. So anybody disagrees with my determinant minus 13? I'm double checking it here. 1 multiplied by minus 1 is minus 1. We must put a minus sign. And then 4 by 3 is, nah, man. I have minus 1 minus 12 is minus 13. So for the person who's telling me it's minus 11, check back your work, right? Right. So we have the inverse now, right? So the inverse, the matrix was thrown across on the other side, and it has become the inverse, right? Right. Abigail, check it back now. Minus 1 minus 12 can never give you 11, right? And you don't need a calculator for that. We know from the rules of addition and subtraction, when the signs are the same, we add and put back the signs of the same or of the larger number. So Abigail, check it back now. You're not even supposed to use a calculator for that, right? Minus 1 minus 12, I guarantee you, is minus 13. All right. So let's move on, right? X and Y goes over here. I have the 1 over minus 13. I need, right? I need to simplify this portion here. You throw up the 6, the X swings up to the top. You have 21 here. We have 6 here. You have 21 here, and we have 6 here, right? We multiply each pair. Right, let's take our time here. 21 multiplied by minus 1 is minus 21. 6 by minus 3 is minus 18. 21 by minus 4 is, I need my calculator for some reason here. Minus 84, and 6 by 1 is 6. To get the number on top, we add the two values on top. 21 plus minus 18, well, 21, minus 21 minus 18. I'm getting minus 39 here. And underneath is minus 84 plus 6 is, guys, some of you are forgetting your signs. It's minus 78. Check it back. A lot of you are telling me the number on top is positive 39. And the number underneath is positive 78. That's not true, right? Minus 21 minus 18 is minus 39. Minus 84 plus 6 is minus 78. Look for your mistakes. Look for your mistakes, right? A lot of people are telling me I'm wrong, but after I ask them, they say, check it back. They say, all right. Did they see their mistakes? I don't think I have any mistakes on the screen right now. Right. Right. So let's simplify now. The 1 on minus 13, everybody inside here, right, gets multiplied by 1 over minus 13. But whenever you're multiplying by 1 over minus 13, you're already dividing everyone inside here by what? Minus 13. So you're dividing the minus 39 by minus 13 and the minus 78 by minus 13. Divide them, and before you make the mistakes, when you divide 2 minus, you get a positive, right? So guys, look at your signs, look, right? Look at your signs. When you divide 2 minus, you're going to get a positive, right? We can't be this close to exams and be making that mistake, right? 39 minus 39 divided by minus 13, I'm getting positive 3. And minus 78 divided by minus 13, I'm getting 6. Right. I just want to point out one thing. This question was lined up. Everything was lined up. The x's was on top each other, the y's was on top each other, and everything else was on the other side of the equal sign. Right. So it had basically no tricks in that question either. All right. So I want you all to do me a favor now as a little revision question. Turn back from last week, and I want you all to multiply these two matrices. Multiply a big matrix by another big matrix. When you take a matrix with 4 numbers and you multiply it by one with 4 numbers again, you get how much answers? 4 answers. So this is a revision exercise. Let's see how fast you can get it out. Good luck. You're going to need it for the next question. Right. So when you're multiplying a big matrix by another big matrix, right? You split the second matrix in 2. And so you take the blue matrix, which is the first matrix, and you multiply by the first half. 2 and minus 3. So it's just, and that will give you the first 2 answers. So the minus 3 goes up to the top as usual. 2 minus 3, 2 minus 3. Multiply each pair, right? Right, let's see. 2 multiplied by minus 3 is minus 6. Minus 3 by 6 is minus 18. 2 by minus 1 is minus 2. Anything multiplied by 0 is 0. To get the first 2 answers, we add the 2 answers on top, 2 answers underneath. I'm getting minus 24 and minus 2. Looking correct there, guys? Look for your mistakes. Look for your mistakes. And then you're going to repeat the procedure. You're going to take the same blue matrix and multiply by the second half, which is the minus 4 and 1. Right? So I could probably do the working across here. Let me see if I can do the working across there. So we take the blue matrix, which is how much? Minus 3, 6, minus 1, 0. And we're going to multiply by the second half, right? Which is the minus 4 and the 1. Well, the 1 swings up to the top. So that means the 4 minus 4 and the 1 walk across. Minus 4, 1. Minus 4, 1. Multiply each pair. All right, make sure I put my multiply signs here. Minus 4 by minus 3 is positive 12. 1 by 6 is 6. Minus 1 by minus 4 by minus 1 is positive 4. 1 by 0 is 0. 12 plus 6 is 18. 4 plus 0 is 4. How much people got all of those correct without my assistance? So you realize it's 2 small questions merged into one big question. You're doing the same thing twice, except with different numbers. Straight out of last week, right? Right. So we're gonna, the reason I'm revising this now is sometimes it is get this hard question, right? It don't come all the time. I haven't seen it in a long time, but you could be the unlucky people to get that very difficult question in the CXC exam. right? So I want to show you it. Let's go. Right. So here's where I'm getting at, right? In the exam, this is the question, by the way, right? It looks a little bit scary, right? They want you to solve for P, Q, R, and S. That is the aim of the question. So you're no longer solving for X and Y. You're solving for 4 things in the exam. Take down the question and I'll show you how to go about it, right? All right, so let's go. Right. So the concept is still the same, right? If we are solving for P, Q, R, and S, if those are the letters we are solving for, that means we need to keep P, Q, R, and S on one side and everyone else on the other side. Okay? So who do we need to throw across? We need to throw across these guys here. Because who is not P, Q, and RS? The red matrix, right? So we have to throw it across. When we throw something across, we get what? The inverse. So, but question, when I throw this matrix across, where will it land? Will it land here, position A, or when I throw it across, will it land in position B? In other words, will it land before the white matrix or after the white matrix? Remember, guys, remember I said something before. When you throw something across, when you're throwing a matrix, it has to jump across exactly one matrix. So if I am throwing across the red matrix, it has to land in position B because it has to jump across one matrix, exactly one matrix. So it will land in position B. Everyone understands that? When you're throwing across a matrix, it has to jump across exactly one matrix. And that will put us in position B. So when this red matrix goes across here and lands in position B, it will become what? The inverse. Because when you throw across a matrix, it has to become the opposite. The opposite of a matrix is called the inverse. So the next line, I kind of put everything out here already. P, Q, R, and S will remain on this side, and the inverse is going to be here. Could you all find the inverse of the red matrix and put it over here for me? Put the value of the inverse over here after the white matrix. For the determinant, we're getting a 3, so it's 1 on 3. Literally half the class is saying something to do with 7, right? Let's see why that is wrong. When we're finding the determinant and we're supposed to multiply the more important diagonal first, so it's minus 4 by 0, we must put a minus sign. Minus 3 by minus 1. So it's minus 3 multiplied by minus 1. Anything multiplied by 0 is 0. We must put this minus sign. Minus 3 by minus 1 is positive 3. 0 minus Sorry, I think I did something wrong here, right? 0, no, I have to correct. 0 minus 3 is minus 3, right? Oh Lord, guys, sorry. I did it wrong. Oh God. And everybody is some people telling me I looking at the wide matrix. My mistake. Oh God, guess the time is catching up with me too. I'm supposed to be finding the inverse of the red matrix and I circle it and everything. Yeah. So guys, I apologize. That's right. But everybody's telling me. Let's find the oh Lord. Let's go. Let's find the inverse here. Multiply these two. 5 multiplied by 2 minus 3 multiplied by minus 1. 5 by 2 is 10 minus 3 by minus 1 is positive 3. Hey, it's correct. 10 minus 3 is 7. The determinant was 7, right? It was 7. So I made a mistake. Right. Let's switch the 5 and the 2. Remember, the more important diagonal we're supposed to switch. So the 2 goes here, the 5 goes here. The less important diagonal, make them the opposite. Don't move them. So we get positive 3 and positive 1. Correct there now, guys? Everything looking perfect? Right. Right. Now let me explain the next line. I want to explain the next line. When we are multiplying things, right? Let me say I have 2 by 3 by 7. I just see it randomly. Is it okay if how the 3 is in the middle? Is it okay I put the 3 first, then the 2, and then the 7? Well, when things are being multiplied, is it okay to rearrange? Is that okay? Yes, it is okay, right? You see, and let me put a fraction into it. Let me say I have 2 multiplied by 1/3 by 4. I just say, sometimes people don't like a fraction in the middle. It is just get to them. It is make it look harder. So instead of having the 1/3 in the middle, and I can put it first, and then the 2, and then the 4. And it won't change anything. It just makes it a little bit easier on the eyes. The same thing over here. Look at these 3 things. We have the white matrix multiplied by 1/7, and this 1/7 is being multiplied by the red numbers. So it come like you have 3 items. So here's what I did to make the multiplication easier. I'm going to put the 1/7 in front. So I will move the 1/7 from the middle and put it here, which you're allowed to do what in maths. Everyone okay so far? You see, having that 1/7 in the middle is just going to complicate things. Let's just put the 1/7 first so we can have the 2 matrices together. Everyone take down up to here. Take down that last line. We not really almost finished, but we have about 10 minutes to finish it. Right. So this was where we left off. The last line here, we had 1 on 7, 21. I have it correct there. I have all my signs correct here, guys. Just want to make sure. 21 on 35. I missed out anything there? All right, cool. I'm good there. Great. So here's what we want to do. We need to simplify everything on this side. So here's my advice. Don't let this 1/7 get to you. You think you all can multiply these two matrices here? Multiply these two matrices, and we just did a question like this, where we take 4 values and multiply it by another 4 values. We just have to split the second matrix into 2. Do that for me and get the 4 answers for me. And then I'll show you what to do with the 1/7. Next two values is supposed to get -9 and -3. That's what I'm getting. -9 and -3. A lot of people are agreeing, right? Look for him, go back to your working. I have to push you to go back to your working this time, right? I have to take off the training wheels here a little bit for you guys. Almost finished. Don't worry, guys. Almost finished. What do you all think the last step is to do? What do you think we're going to do with that 1/7? And we have to multiply every one inside there by 1/7. But multiplying by 1/7 is the same exact thing as what? Dividing everybody by 7, because the 7 is underneath. So divide everyone by 7, and you can round off your answer to 2 decimal places. Try your best to go to 2, and you will get 4 answers. No coincidence. And you have 4 letters on this side. Well, this answer will be P, this will be Q, this will be R, and this will be S. And that will be the end of the question. After you divide everyone by 7 and round it off to 2 decimal places, some people might just leave it as a fraction, like they might just leave it as -11/7, right? Right. Guys, I'm real sure that's not checking it back. I'm real sure it's -11. Check it back, Adrian. Check it back. It's -11. Because you'll end up with -8 -3. That is what you will end up with. -8 -3. And that will give you the -11. All right, so 11 divided by 7. I'm getting -1.57 here, -1.29 if I do it correctly. Real minus here, right? -0.86. That's the one. -0.43. Those are my 4 answers. So P, this here is the answer for P. This one is Q, this is R, and this is what? S. Right? Like I mentioned, guys, 2 decimal places is the standard for the maths exam. I think we mentioned this over and over in class already. 2 decimal places is the standard. I mean, if you want to take the chance and round off differently, you can, but I will not advise it because you will lose marks. Right? Right? So, and remember, if the 3rd decimal place is 5 or more, you have to add 1, right? So that's 3 divided. Somebody's telling me my answers. Last one is no, the last one is correct. The last one I'm getting -0.428. So if the 3rd decimal place is 8, I have to add 1 to the 2. It's 5 or more. When you round off, you have to round off properly. You just can't say, I'm going to round off. You have rules to round off.